All right, today we're talking about Note 7.5, logarithmic functions. So today we're looking at a new function called log, and log, just like exponential, has various bases that we can use, but today we're going to be exploring log base 2. This is where your base will be on a log. It's kind of like a subscript instead of a superscript. And then we're also going to be exploring log base 10. So you'll notice this log here does not have the number 10 written. So if there is no base written, 10 is implied. So 10 is implied. So this is log base 10, and it is also sometimes called the common log. Okay, so we've never looked at logs before. I picked out some various x values that I would like for you to plug into your calculator by using these steps. So I wrote out the work for you, and I'm going to show you here on the calculator screen. When I plug in -2 for x, right here in this function on the calculator, plugged in -2 for x, you see I got an error. Same goes for -1, same goes for 0. Okay, I got error, error, error until I got down to 1/8. When I plug in 1/8 for x into the calculator, I got -3, and then so on and so forth. And I can show you how to do this in class. Okay, so all I did was plug in various x values to give me y values that correspond so I can have something to plot. So the reason I chose a couple of negative x values and 0 is because you'll notice all of the negative x values and 0 have an error. That is because you guessed it, we have a vertical asymptote on this graph at x equals 0. So I have an asymptote here at x equals 0. My first point that I'm going to try my best to plot is going to be 1/8 -3. So that means my x value is 1/8, and I go down -3. The next point I'm going to plot is 1/4. So 1/4, I still haven't even gotten to 1, and -2. Okay, and then I've got 1/2, so just going x value of 1/2, down 1, and then 1, 0, 2, 1, 1, 2, 3, 4, 2, and 8, 3. So the reason I chose such small x values is because I wanted you to see what was happening to this graph as my x values get closer and closer to 0 here on the right. This graph is continuously going down and down and down and just hugging that asymptote, okay? So very similar with a log base 10. When I have a log base 10 and I plug in -2, -1, and 0 for x values, I get error. That is because I also have an asymptote here on x equals 0. Okay, the first x value that I chose, and you'll see why, not because I'm trying to be cruel, but the first x value I chose is 1/1000th. So that is very, very small. It's very close to the y-axis here, and -3. And then 1/100th, -2. 1/10th, -1. So we're still very small x values here. And then 1, 0, finally, whole numbers. And then 10, 1, 10, 1. And then I can't go further than that because I definitely don't have 100 over here on my graph, but know that it takes all the way till x is 100 that I reach 2 for a y value. So this graph is very, very, very slowly getting taller. Very, very slowly, okay? And also hugging the asymptote here on the positive x value side. Okay, so that is how you graph logarithmic functions. Let's look at the domain and range. So for the domain of this first one here, because of this asymptote, I can never have negative x values. So my domain for this is always going to be, unless I transform it, x is greater than 0. Not greater than or equal to because of the asymptote. My range, even though it's slow, it's not slow going down, but even though it's slow going up, it goes all the way down and all the way up. So that's all real numbers, that funky notation for all real numbers. My asymptote is at x equals 0. Okay, and for this one I do not have a y-intercept because of the asymptote. I have an x-intercept here at 1, 0. Okay, if I'm looking for the max and min, remember I'm looking for the highest point and the lowest point from 1 to 5. Well, I've got 1 on the table here, but I don't have 5, so I need to find out, using my calculator, what log base 2 of 5 would be. Let's find out what it would be. So log base 2 of 1 is 0. That would be my min, because 0 is definitely smaller than 2.32. So my max is going to be 2.32. Okay, and then let's look over here likewise on my domain and range here. I've got the same asymptote, so my domain is going to be x greater than 0. My range, even though this one's super slow, it's going down for sure, but slowly going all the way up, so all real numbers. My asymptote is also at x equals 0. You'll notice my y-intercept is at 1, 0. Likewise here, I know my y value when x is 1, but I don't know my y value when x is 5. So I need to type into my calculator log, and remember that's base 10 because nothing's written. Log base 10 of 5 is approximately 0.70. So my min when x is 1 is y equals 0, and my max, so my min occurs at 1 and my max occurs at 5, and that is y equals 0.70 when I round, 0.70. Okay, so what I want you to notice about these graphs, and you might have to refer back to your notes 7.1 about exponentials, what I want you to look at is the points of y equals 2 to the x and y equals log base 2 to the x. If you go back and look at these points here, 3, 8, 8, 3, 4, 4, 2, 2, 4, 2, 1, 1, 2, 1, 0, 0, 1. Okay, my points are switched. The domain and range of exponential and log, both base 2, are switched. Okay. So the asymptote for y equals 2 to the x, remember when we referred to y equals 2 to the x, the asymptote was y equals 0. And the asymptote for log base 2 to the x was x equals 0. So the graphs are, if you already guessed it, a reflection over the line y equals x. Thus, big point, y equals 2 to the x and y equals log base 2 to the x are inverses.